What if the universe ends tomorrow? No warning, no time to prepare, just gone. Sounds like a sci-fi movie, right? But here's the crazy part. Scientists actually have theories about how the universe could meet its ultimate fate, from a slow, icy death to a sudden cosmic collapse or even a reality-shattering event that happens instantly. These aren't just wild guesses, they're backed by physics. And the scariest part? Some of them could happen without us ever seeing it coming. So what's the truth? Let's dive into the ultimate doomsday theories and find out how everything we know could end. The Big Freeze. Alright, picture this. You're walking outside one night and for some reason the stars look dimmer. Not just one or two, all of them. The sky feels colder, emptier. Now what if I told you that this is exactly how the universe might end? Not with a bang, not with destruction, but with a slow, agonizing freeze. Scientists call it the Big Freeze or heat death, and honestly it's one of the scariest ways for the universe to go. Right now, our universe is expanding. Galaxies are moving away from each other like people trying to avoid an awkward conversation. But the problem? They never stop moving. Ever. The farther they go, the colder everything becomes. Stars will die, galaxies will vanish, and black holes will eventually evaporate, leaving behind a vast, empty, frozen void. Imagine the last star in the universe, flickering like a dying candle. No more warmth, no more light. Just eternal, infinite darkness. Even atoms might stop vibrating, meaning time itself could just stop. Forever. But here's the real kicker, this isn't something that happens in an instant. It's a slow, inevitable process that would take trillions upon trillions of years. So, if you're worried about waking up tomorrow to an ice-cold void of nothingness, don't be. We still have time. For now. The Big Rip. Okay, imagine you're holding a piece of paper. Now slowly, tear it in half. Now again, and again. Until there's nothing left. Now, apply that same concept to the entire universe, except instead of paper, it's planets, stars, galaxies, even atoms. Welcome to the Big Rip, a theory that suggests one terrifying possibility. Dark energy could one day become so powerful that it overcomes everything. Gravity, nuclear forces, even the very fabric of space itself. Right now, dark energy is this mysterious force making the universe expand faster and faster. But what if that acceleration keeps increasing? What if, in a distant future, galaxies are torn from each other? Then solar systems? Then planets? Eventually, even your body would be stretched and ripped apart, atom by atom. And the worst part, scientists estimate that if the Big Rip is real, it would happen in a sudden, unstoppable chain reaction. First, galaxies separate. Then, black holes dissolve. Then, planets and moons start drifting away, until in the final moments, boom! Space-time itself is shredded, and the universe as we know it ceases to exist. So, while we might be safe for billions of years, if this theory turns out to be true, well, let's just say we won't see it coming. The Big Crunch. Alright, let's flip the script. What if, instead of expanding forever, the universe suddenly decided to reverse? Imagine watching a movie of the Big Bang, but in reverse. Galaxies stop moving outward and start falling back toward each other. Space itself shrinks. Stars collide. The entire universe begins to implode under its own gravity. This is the terrifying possibility of the Big Crunch. At first, it wouldn't be noticeable. The cosmos is vast, and these changes would happen over billions of years. But eventually things would get weird. Galaxies would merge in violent collisions, black holes would devour everything in sight, and temperatures would skyrocket as matter condensed. Now, picture the very last moments. Everything, stars, planets, dust, even light itself, squeezed into an unimaginable singularity. A point so dense, so hot that the laws of physics completely break down. Sound familiar? Yep. This singularity would look exactly like the one that started the Big Bang. Which raises the question, what if this isn't the first time it's happened? What if the universe doesn't just end, but resets? The Big Bounce theory suggests that once the universe collapses, another Big Bang could ignite a new beginning. A fresh universe with new galaxies, new planets, maybe even new versions of us. So is the Big Crunch the end of everything or just a cosmic reboot? We don't know. But if history really does repeat itself, the universe may be stuck in an endless loop of birth, death, and rebirth. Kind of poetic, isn't it? Vacuum Decay. Alright, this one is pure nightmare fuel. Unlike the Big Freeze or the Big Crunch where the universe takes billions of years to die, this could happen at any moment. Without warning. Let me introduce you to Vacuum Decay, or as some physicists like to call it, the Big Slurp. Sounds funny, right? Yeah, not when you realize what it means. Right now our universe exists in what's called a false vacuum, kind of like standing on thin ice. It feels stable, but beneath us, there might be something more fundamental, something more real. If a quantum fluctuation or some bizarre high-energy event were to trigger a shift, a tiny bubble of true vacuum could form. And guess what? That bubble would expand at the speed of light. You wouldn't see it coming, you wouldn't feel it, it would just happen. 1 second the universe is here, the next, gone. The laws of physics would change instantly. Atoms would stop being atoms. Time and space would cease to exist as we know them. It sounds like sci-fi, but this isn't some horror movie plot, it's actual science. Some physicists believe that if the universe is truly in a false vacuum state, then vacuum decay is inevitable. The only good news? If it happens, we wouldn't have time to process it. No suffering, no pain, just poof. So, will we wake up tomorrow and find out the universe has been rewritten? Probably not, but the possibility alone is enough to keep some scientists awake at night. Sleep well. The big bounce. Alright, let's think outside the box for a second. What if the universe never really ends? What if, instead of collapsing into nothingness or freezing over, it just bounces back? Imagine a giant cosmic heartbeat, expanding, collapsing, expanding again. This is what scientists call the big bounce. It all starts with a big crunch, where everything gets pulled back together, condensed into a singularity. But instead of staying trapped, something triggers another big bang, a new universe bursting into existence, repeating the cycle all over again. And here's where things get really crazy. What if every new universe is just slightly different? Maybe in one version the laws of physics are the same, but galaxies form in completely different places. Maybe in another, the speed of light is different or gravity is stronger. And maybe, just maybe, there's another version of you out there living a completely different life. This theory makes the universe feel less like a one-time event and more like an eternal process. The end? It's just the start of something new, over and over again. And if that's true, then maybe this isn't the first time we've had this conversation. Maybe in some past version of the universe you've already heard this before. And maybe, just maybe, you'll hear it again. The role of dark energy. Okay, now let's talk about the real mystery here, dark energy. If the universe's fate is a movie, dark energy is the director. We can't see it, we don't fully understand it, but it's shaping everything. And depending on what dark energy really is, it could decide which of these doomsday endings actually happens. Right now, dark energy makes up about 68% of the entire universe. It's like a force that's pushing everything apart, making space expand faster and faster. But here's the scary part. We have no idea what it is. Is it a constant force? Will it get stronger? Or could it suddenly change? If dark energy stays constant, the universe might just expand forever, leading us straight into the big freeze. And if it gets stronger, we might be headed for the big rip, where space itself is torn apart. But if it weakens, gravity could take over again, pulling everything back for a big crunch. And here's something even crazier. What if dark energy isn't just controlling this universe, but all universes? Some scientists think that dark energy could be linked to the multiverse, meaning that whatever happens to our universe is just a tiny piece of something much, much bigger. So, will dark energy let the universe drift into an icy grave, rip it apart, or start the cycle all over again? The truth is, we don't know. But one thing's for sure, dark energy is the key to everything. So, is the universe destined for a slow freeze, a violent collapse, or something even stranger? The truth is, we may never know until it happens. But one thing's for sure, the cosmos is full of mysteries waiting to be unraveled. If you love exploring the mind-blowing possibilities of science in the future, make sure to subscribe to InnoVision Tech for more deep dives into the unknown. What do you think will be the universe's ultimate fate? Let's discuss in the comments. What if right now, in another universe, you're living a completely different life? Maybe you're a famous actor, a billionaire, or even an astronaut exploring a distant planet. Sounds crazy, right? But what if science says it's possible? The idea of parallel universes isn't just science fiction, it's something real physicists are actually exploring. But here's the big question. If alternate realities exist, could we ever travel between them? Could déjà vu be a glitch between worlds? Stick around, because we're about to dive into one of the biggest mysteries of the universe, and you might never see reality the same way again. The multiverse concept. Have you ever stopped to think, what if there's another version of you, right now, living a completely different life? Maybe in some alternate reality you're a famous musician, a billionaire, or even an astronaut exploring Mars. Sounds crazy, right? But hold on. Science suggests that this idea might not be as far-fetched as it seems. The multiverse theory proposes that our universe is just one of many, an infinite number of realities where every possible version of your life plays out. In one universe, you might have taken that job offer you turned down. In another, you never even existed. It's like a cosmic choose-your-own-adventure book, but every choice actually happens in a separate universe. Why does this idea matter? Well, if alternate universes exist, it changes everything we know about reality, fate, and free will. What if our dreams, déjà vu moments, or gut feelings are actually glimpses of another version of ourselves living in a parallel world? What if those unexplained coincidences, meeting a stranger who feels oddly familiar, or predicting an event before it happens, aren't coincidences at all? The possibility of an alternate universe isn't just science fiction. Physicists, mathematicians, and even philosophers have spent years trying to crack this mystery. Could it be that we are just scratching the surface of something far bigger than we can comprehend? Buckle up, because the journey into the multiverse is about to get a lot deeper. Scientific theories of parallel universes. Okay, so let's get one thing straight. This isn't just wild imagination. There are actual scientific theories that hint at the existence of multiple universes, and they come from some of the brightest minds in physics. One of the biggest ideas? The many worlds interpretation. This comes straight from quantum mechanics, the branch of physics that deals with the tiny, bizarre world of particles. According to this theory, every time a decision is made, every single choice, no matter how small, the universe splits into multiple realities where every possible outcome actually happens. Right now, in some alternate universe, another version of you picked a different career, moved to another country, or even skipped watching this video. Then there's the cosmic inflation theory. Ever heard of the Big Bang? Scientists believe that during the very early moments of our universe, it expanded at an insane rate, like a balloon inflating super fast. This theory suggests that different parts of space might have inflated at different speeds, creating separate independent universes, each with its own laws of physics. That means somewhere out there could be a universe where gravity works differently, where light travels at a different speed, or where time itself doesn't even exist. And get this, some researchers even believe that black holes might be portals to other universes. When something falls into a black hole, it gets crushed into oblivion. Or does it? Some theories suggest that instead of being destroyed, that matter is actually transported to another universe entirely. So what does this all mean? If these theories hold up, then parallel universes might not just be possible, they might be inevitable. The real question is, will we ever find a way to travel between them? Implications of alternate realities. Now, here's where things get personal. If alternate universes really exist, then who are you? Are you just one version of yourself out of an infinite number of possibilities? Think about it. If there are multiple realities where different versions of you exist, does that mean your identity isn't as unique as you thought? Let's say you made a life-changing decision a few years ago. Maybe you quit your job, moved to a new city, or broke up with someone. According to the multiverse theory, in another universe, there's a version of you who made the opposite choice. That version of you might be living a completely different life right now. Maybe they're thriving, maybe they're struggling, but either way they exist. This also raises the question, how much of our lives are actually in our control? If every possible choice creates a new reality, then, technically, every version of your life is happening somewhere. Does that mean free will is just an illusion? Or does it mean that every decision, no matter how small, matters more than we ever realized? And here's something even weirder. What if we sometimes feel these alternate versions of ourselves? Have you ever experienced a moment where you knew something was going to happen before it did? Or felt an unexplainable connection to a place you've never been before? What if those are glimpses of another reality bleeding into our own? If alternate universes exist, then your entire sense of self might be way more complicated than you ever imagined. Maybe you're not just you, you're part of something much, much bigger. Cultural and philosophical perspectives. The idea of parallel universes isn't just a scientific curiosity, it's something that has fascinated humans for centuries. Across cultures, religions, and philosophies, there have always been stories about other versions of reality. Take Hinduism and Buddhism, for example. Both traditions talk about the idea of multiple worlds and different versions of existence. In some interpretations, karma doesn't just affect your next life. It could also play out across multiple realities at once. Could these ancient beliefs be an early glimpse into what science is now exploring? Then there's philosophy. Ever heard of the what-if paradox? It's the idea that every decision creates an alternate path. Some philosophers believe that every choice we make splits reality, which means infinite realities exist, each one shaped by a different version of your past decisions. Sound familiar? That's basically the many worlds interpretation, but through the lens of philosophy instead of physics. And of course, we see the idea of alternate realities everywhere in pop culture. From Marvel's Multiverse of Madness to Stranger Things, from Rick and Morty to Interstellar, the concept of multiple universes is a storytelling goldmine. Why? Because deep down we all wonder, what if my life had gone differently? But here's the real kicker. What if these stories aren't just fiction? What if we're drawn to these ideas because on some subconscious level we know there's truth to them? Maybe, just maybe, the reason we love stories about parallel universes is because our minds are already connected to them in ways we don't fully understand yet. Technological advances. Alright, let's get to the big question. Can we actually prove that alternate universes exist? Right now, we can't exactly hop into a spaceship and visit Earth 2, or shake hands with an alternate version of ourselves, but that doesn't mean scientists aren't trying. One of the most exciting areas of research is quantum computing. Unlike regular computers which use bits, quantum computers use qubits, which can exist in multiple states at once. Some physicists believe that this strange behavior hints at parallel worlds interacting with our own at the microscopic level. Could quantum computers one day help us access these other realities? Then there's the Large Hadron Collider, the massive particle accelerator beneath Switzerland. Some scientists speculate that high-energy particle collisions could create tiny, mini black holes, which might provide evidence of other dimensions or universes. In other words, we might be closer than we think to unlocking the secrets of the multiverse. And let's talk about dark matter, the mysterious invisible substance that makes up most of the universe but doesn't interact with light. Some scientists believe that dark matter could be leaking in from parallel universes. Imagine that. What if an entire hidden reality is right next to us, but we just don't have the tools to see it yet? The bottom line? We might be on the verge of one of the biggest discoveries in history. If alternate universes exist, science will find a way to prove it. And who knows? Maybe one day, we'll find a way to travel between them. The allure of the unknown. So after all of this, where does that leave us? Is there really another version of you out there living a different life? Maybe, maybe not. But here's the thing. The possibility alone changes everything. Think about it. If alternate universes exist, it means every choice you've ever made has played out somewhere. Every dream you've had, every risk you didn't take, every what-if moment, it all exists somewhere in the vast multiverse. And if that's true, then what does it say about the life you're living right now? What if we're more connected to these alternate realities than we realize? What if those strange moments, déjà vu, vivid dreams, unexplainable instincts, aren't just random, but glimpses of something bigger? What if the universe isn't just a place but a network of infinite possibilities, all playing out at the same time? One thing's for sure, the more we learn about the universe, the more mysterious it becomes. And whether or not we ever find proof of the multiverse, one thing is undeniable. The search for answers is what makes us human. Because in the end, we aren't just looking for other universes, we're looking to understand our own. The idea of alternate universes is mind-blowing, but what if it's more than just theory? What if every choice, every possibility is playing out somewhere right now? Science is getting closer to unlocking these secrets, so who knows what we'll discover next? If you enjoyed this deep dive into the unknown, make sure to subscribe to InnoVision Tech for more mind-expanding content. Hit that like button, drop a comment, and let's keep exploring the future together. See you in the next one. Have you ever wondered just how far we can see into the universe? How far back in time can we peer to uncover the mysteries of the cosmos? The universe is vast, and every new discovery helps us understand it just a little bit more. But here's the big question. What if we could observe galaxies that formed just a few 100 million years after the Big Bang? Imagine what secrets they could reveal. Today, we're diving into the discovery of the most distant galaxy ever found and exploring how far we can actually see. Ready to join the cosmic journey? Let's go! Introduction to Cosmic Exploration. When we gaze up at the night sky, it's hard not to wonder about the vastness of the universe. How far does it really go? And what mysteries lie beyond the stars we see with the naked eye? These are the kinds of questions that drive astronomers and space enthusiasts alike to explore the cosmos. Over the centuries, our understanding of the universe has evolved significantly, thanks to groundbreaking technological advancements and the courage to venture into the unknown. In the early days of space exploration, the ability to view distant galaxies was limited by the tools available to astronomers. Telescopes allowed us to look deeper into space than ever before, but the farther we looked, the more we realized how much we were still missing. That all began to change with the advent of space telescopes like Hubble. Hubble gave us unprecedented views of the universe, showing us galaxies that were millions, even billions of light-years away. Yet even Hubble's extraordinary capabilities were still bound by the limits of the visible light spectrum. But what if we could see beyond visible light? What if we could look at the universe as it existed in its infancy, just a few hundred million years after the Big Bang? With the launch of the James Webb Space Telescope, this possibility became a reality. Webb's infrared capabilities allow us to peer further into space and further back in time than any telescope before it. Thanks to Webb, astronomers have discovered a galaxy so distant that it has completely transformed our understanding of the early universe. But what exactly does this discovery mean? How far can we really see, and what can it tell us about the birth of galaxies? Let's dive into this groundbreaking exploration of the most distant galaxy ever discovered. The role of the James Webb Space Telescope. Imagine being able to see something no one else has ever seen before. That's exactly what the James Webb Space Telescope enables scientists to do. Launched on December 25, 2021, JWST has quickly become one of the most powerful and influential tools in the history of astronomy. Unlike the Hubble Space Telescope, which primarily observes invisible light, Webb is equipped to observe infrared light, a type of light that is invisible to the human eye. Infrared observations are crucial for studying distant objects in the universe because, as light travels across the vast expanse of space, it stretches out due to the expansion of the universe. This stretching causes light to shift to longer wavelengths, which we detect as infrared light. Essentially, the farther away a galaxy is, the more its light has been stretched, making it visible only in the infrared spectrum. That's where Webb comes in. Thanks to its cutting-edge instruments, the JWST is able to capture infrared light with an unprecedented level of detail. One of Webb's primary missions was to look deeper into the universe than ever before, and to study the very first galaxies that formed after the Big Bang. This is a critical task because understanding the birth and evolution of galaxies is key to understanding the origins of the universe itself. The JWST's ability to see through cosmic dust and gas allows it to provide a clearer picture of the earliest galaxies, which were previously invisible or difficult to study. By observing these galaxies, astronomers can unlock the secrets of how stars and galaxies came together in the early universe, offering new insights into the conditions that led to the creation of the cosmos as we know it. Webb's findings are already shaking up our understanding of the universe's evolution, and one discovery in particular has captured the attention of scientists and space enthusiasts around the world. But what exactly did they find? Let's take a closer look. Discovery of JADES GSZ 14-0. In May 2024, astronomers using the James Webb Space Telescope made a groundbreaking discovery that would change the way we view the universe. They identified a galaxy named JADES GSZ 14-0, located at a staggering redshift of 14.32. But what does that mean? Well, the redshift of a galaxy tells us how far away it is and how much its light has stretched as it traveled across space. A higher redshift indicates a galaxy that existed closer to the beginning of the universe, meaning JADES GSZ 14-0 is one of the most distant galaxies ever observed. At a distance of around 13.5 billion light-years from Earth, JADES GSZ 14-0 is located in a time just under 300 million years after the Big Bang. This is an incredibly important finding because it provides a glimpse into the earliest stages of the universe, when galaxies were first beginning to form and evolve. To put this into perspective, if we were looking at Earth from this distant galaxy, we would be seeing our planet as it was just a few million years after life began to emerge. The discovery of JWST 14.0 pushes the limits of what we thought was possible. It challenges the existing models of galaxy formation, suggesting that galaxies were able to form and evolve much faster than previously anticipated. The early universe was a chaotic place full of energy, gas, and radiation, yet somehow in this tumultuous environment, galaxies like JWST 14.0 were able to emerge. The fact that we can observe such an ancient galaxy is a testament to the power of modern technology, and it raises important questions about how galaxies formed in the first few hundred million years after the Big Bang. What does this mean for our understanding of the universe's infancy, and how much further can we see? These are just some of the exciting questions this discovery raises. Characteristics of JWST 14.0. When scientists first observed JWST 14.0, they were amazed by its size, brightness, and activity. Three characteristics that make this galaxy truly remarkable. Despite its extreme distance, JWST 14.0 appears to be quite luminous, meaning it emits an incredible amount of light for its age. This is particularly significant because galaxies in the early universe were expected to be much smaller and dimmer, especially in comparison to the massive mature galaxies we observe today. So, how is this galaxy so bright? The answer lies in the rapid rate of star formation within the galaxy. Spectroscopic data gathered by the JWST reveals that JWST 14.0 is actively producing stars, and this star formation process is likely responsible for its high luminosity. The fact that this galaxy is so active in its star formation so soon after the Big Bang challenges current models of how galaxies evolve. It suggests that galaxies in the early universe may have formed and matured much faster than we previously thought. Another fascinating characteristic of JWST 14.0 is its size. The galaxy spans over 1,600 light-years across, which is a significant size for a galaxy so young. This large size further challenges our understanding of how galaxies grow and evolve in the early stages of the universe. Astronomers expected early galaxies to be smaller and less structured, but JWST 14.0 bucks that trend. Its size and activity make it a valuable object of study for astronomers who are trying to piece together the story of galaxy formation. Additionally, the galaxy's composition is of great interest to researchers. Observations of JWST 14.0 have revealed the presence of key elements like hydrogen and oxygen, which are essential ingredients for star formation. These findings provide critical insights into the processes that fueled the creation of the first stars and galaxies. By studying galaxies like JWST 14.0, astronomers are beginning to build a clearer picture of the early universe and how the first stars and galaxies came to be. It's discoveries like this that push the boundaries of human knowledge and open up new avenues for exploration. What more can we learn from galaxies like JWST 14.0? The future of cosmic exploration looks incredibly exciting. Implications for cosmology. The discovery of JWST 14.0 offers more than just a fascinating glimpse into a distant galaxy. It holds profound implications for our understanding of cosmology, the study of the universe's origin, structure, and evolution. As we peer deeper into the cosmos, we're not just uncovering more galaxies, but we're uncovering the very processes that shaped the universe in its infancy. JWST 14.0, located a mere 300 million years after the Big Bang, provides critical insights into the early universe when stars and galaxies were first forming in the chaotic environment that followed the Big Bang. This discovery is crucial for understanding a period in the universe's history known as the Cosmic Dawn, the time when the first stars lit up the universe, pushing back the darkness of the cosmic dark ages. The light from these early stars helped to ionize hydrogen gas and set the stage for the formation of more complex structures like galaxies, black holes, and even planets. JWST 14.0, with its high star formation rate and abundant luminous activity, serves as a cosmic time capsule from this pivotal moment in the universe's evolution. Moreover, this galaxy challenges our models of galaxy formation. Until now, scientists believed that galaxies in the early universe would be much smaller and less developed, but JWST 14.0's surprising size and brightness suggests that galaxies might have formed much faster and more efficiently than we previously thought. This could alter our understanding of how galaxies evolve over time and may prompt astronomers to reconsider theories about the conditions required for galaxy formation in the early universe. As we continue to observe galaxies like JWST 14-0, we may uncover even more surprises that will reshape the way we think about the birth and growth of galaxies across the cosmos. Future prospects. The discovery of JWST 14-0 is just the beginning of an exciting new chapter in cosmic exploration. With the James Webb Space Telescope continuing its mission, astronomers are poised to uncover even more distant galaxies, pushing the boundaries of our knowledge further than ever before. While JWST 14-0 holds the current record as the most distant galaxy ever observed, there's no telling how much farther we can look into the universe's past. The future of astronomy is incredibly bright thanks to the capabilities of Webb and other upcoming space missions. Webb's infrared instruments have allowed scientists to see galaxies from a time long before our solar system even existed. And these observations are not only helping us learn about the universe's origins, but also providing clues about its future. As we gather more data on galaxies like JWST 14-0, we'll continue to refine our understanding of the universe's history, including the formation of stars, galaxies, and black holes. The implications of these discoveries go far beyond the early universe. They also hold the key to understanding how galaxies evolve over billions of years, which will help us predict the future of our own galaxy, the Milky Way. In the coming years, astronomers expect to discover even more galaxies that existed during the universe's early stages, revealing new secrets about the formation of cosmic structures and the evolution of the universe itself. As technology improves and our tools become even more advanced, the quest to understand the universe's earliest epochs will only accelerate. With each new discovery, we take one step closer to understanding how the universe came to be, how it evolved, and where it's headed in the future. The most distant galaxies are not just objects of fascination. They are keys to unlocking the mysteries of the cosmos, and the journey to uncover them is just beginning. Thanks for tuning in to InnoVision Tech. We've just scratched the surface of the universe's deepest mysteries, but there's so much more to discover. What do you think? How far do you believe we can see into space? Drop your thoughts in the comments below, and don't forget to hit that like button if you enjoyed this journey with us. Subscribe for more fascinating tech and space discoveries, and stay tuned for the next adventure. Until then, keep exploring the infinite possibilities.